Hello, in this video, we're going to be learning how to draw resonance structures. The first example I have here is this compound. Now, if you're given a compound like this and you're asked to draw the resonance structure, one thing you need to look at is the charges, okay? Where are your charges? Where is the double bond? And what kind of charge do you have? So here I have a positive charge. When you have a positive charge, the double bond or lone pairs. So note it, if you have a double bond and you have a positive charge, this double bond moves towards the positive charge, okay? If you have a lone pair, it moves towards the positive charge. If you have a negative charge somewhere, it also moves towards the positive charge to form, of course, to form a double bond, right? So this is one of the rules you should at least note down. Okay, so now that we know these rules, it means that for us to form a resonance form of this compound, this is going to be moving towards this carbon. Now, when it does that, the resonance form of this compound is going to look like this. So you have this double bond, new double bond forming here. And of course, we know that this carbon would then bear the positive charge. So there will be a transfer of the positive charge. Now, you might ask, why do we have this positive charge here? That is because this carbon here is losing a bond, okay? This bond is still on this carbon, but this carbon has lost that bond. So donating the electron, it kind of donated an electron, that is why it's gaining this positive charge. Okay, so the positive charge transfers from this part to that part. So this here would be your only resonance form for this compound. And that is because the only thing you can have again would be going back to the original compound that you had. So once you get to this point whereby you can no longer go further, then you know that you have achieved the resonance structure of that compound. So this is what you have for this one. Now, the next one is this example. So we're asked to write the resonance form of this compound. The first step is please put in your lone pairs. Now, oxygen belongs to group 6 in the periodic table, okay, which means that oxygen has 6 valence electrons. It has used 2 of the valence electrons to do this bonding here. Therefore, you have 2 more remaining. 4 more remaining, 4 electrons, and these electrons, they pair up to form what we call lone pairs. Now, if you remember at the beginning, I said that you would move from a lone pair to a positive, negative to a positive, or a double bond to a positive, right? So this lone pair is going to be going towards this carbon. And what we'll have as our resonance form would be double bond here, okay? And of course, you'll be having just one lone pair now. Now, that lone pair that was donated would then be replaced by a positive charge. So you have this positive charge transferring to that point because it donated the electron, right? So now it has a positive charge. Okay, so this would be the resonance form. And whatever step you take, it would be this one going back again towards that and forming this back. So that is why we have this 2-headed arrow to show that you can go back to where you started from. So that will be the resonance form of this particular compound. Right, so for this one here, we are asked to draw the possible resonance structures for this compound, okay? Now, if we also go by the rule, negative towards a positive charge, okay? Now, in this case, this carbon has a partial positive charge on it. So you can start from any of the negative. This is going to draw this one in. And when that happens, carbon cannot have more than 4 bonds going on at the same time. So that will force this one here to break. Okay, so you see the line. So your first resonance form is going to look like this. So you have this C with a new double bond O here. Now, this double bond O, you use one of the lone pairs to form that pi bond. So this is going to become just 2 lone pairs, right? And this is not affected in any way, so we just leave it the way it is. You still have it intact. Now this one, because you've broke a bond here, this bond was broken, so we're going to be having this negative charge transferring to that. If this was positive, that would have transferred, okay? But this is negative, so what you have here transferred would be a negative charge, okay? The bond was broken, and this oxygen is lacking one bond, so it will be negative, okay? Now, this is one resonance form. If we go ahead and move from here, this bond will be forced to break again because we can't have more than 4 bonds on carbon, right? Now, our next resonance form will become C with this a negative charge here. This one has broken, formed back a negative charge. So the charge also transfers, this charge here transfers to that. And we have this oxygen now becoming a double bond and only 2 lone pairs now without any charge. So these are all the possible structures you can have. You can move from here back to this one, okay? All right, so that is all the possible resonance form for this particular compound. Now, let's go on to this one. So in this case, we're going to start from the double bond. Now, when you have this type of compound, the first step is move your double bond towards this, that is 1. This is going to give us our first possible resonance form, which is this with a negative charge, okay? With this losing its electron, it gains back 2 electrons. So it loses the bond and gains 2 electrons back and with a negative charge. And of course, because of that, this, because it donated the electron back to oxygen, gains a positive charge, okay? Now, this now will be pulled in towards that positive charge, okay? And when that happens, you have another form, which is going to look like this. So you have a double bond here, and you have this still the way it is, okay? Remember, when this bond goes there, this positive charge is, transferred to this carbon because it lost electrons, okay? So it transfers there. Now we have all the possible structures. Why do I say we have all the possible structure? If I move from here now, let me just do a total reverse. I can move in here, and this will be forced to move in here, and that totally gives me what I have here, okay? So once you're able to get what you have back, then that means you can't go further than where you are, okay? So whatever I do now would take me back to the starting material. All right, for this one, first put in all our lone pairs, okay? For oxygen, we have these 2 lone pairs because it made use of 2 electrons, remaining 4. It has 6 valence electrons. This one also the same thing, okay? Now we have this. Where are we going to start from? So we can still start from the top, moving and form. So all the possible resonance form is what you have been asked to give, okay? So this is one possible form. So when it forms this, there has to be a positive charge here, right? Because this carbon has donated its electron. Now this will be forced to go in there, okay? When it goes there, you then have another form of this compound, which is going to look like this. Okay. remember that when this moves here, this positive charge is now transferred to this carbon, right? So you have that. And this is where another step is taken. Now, the lone pair here is going to go ahead and form a double bond there. And when that happens, you have another form of this compound that would look like this. So you would have a double bond here with the oxygen and this. And of course, this positive charge will be transferred to this oxygen. Okay, this one is still intact, and your oxygen is still intact. The way it is, okay? So you have it that way. And now, whatever move I make from this point is going to totally take me back to the beginning. So I can make one move and get me back to the beginning. So if I do this, remember this is a positive charge, right? So I can move like that from the negative end towards the positive charge. This is one step. Okay, let me use another color so you can see it properly. This is one step. This is two steps. This is the last step. Now this last step is going to take me back to where I started from, okay? So that shows me that this is the end of my resonance structures. That is all the possible resonance structures this compound can have. So this is how you can draw resonance structures. I hope this has helped you somehow, and have a nice day. Bye.